example, we're going to consider the following circuit. We have a battery and a little resistor in series there, and then we're going to have a parallel connection that has 3 components to it. So here's all 3 of these are in parallel with each other. All right, so if you remember back in lab, this would be sort of 3 things piggybacked into one another. And we're going to give these resistances. So here's 1 ohm, this is 2 ohms, 4 ohms, 6 ohms. Ohms are a little wonky there. 6 volts for the battery. And we are going to try and find the current in each resistor and the current leaving the battery. And so the first thing we can start with is actually this. And for most of these problems, you actually always want to reduce your circuit back down to the simple example that we talk about, where we have a battery and 1 resistor, because that gives you the current that is flowing out of the battery. All right, so we need to figure out this total equivalent resistance. And what we're going to do is first combine these 3 in parallel, and then we'll put this one in series at the end. And so for parallel, again, it's the inverse. And so that's going to be 1 over 2 ohms plus 1 over 4 ohms plus 1 over 6 ohms. And if you want, you can just throw these in a calculator, but you know, if you remember your fractions from way back when, you can find the common denominator. 2, 4, and 6 have a common denominator of 12. And so that's 12, 6 over 12, plus 3 over 12 ohms, plus 2 over 12 ohms. And so 6 plus 3 plus 2 is 11 over 12 ohms. And so we're going to take the inverse of that, and it's going to be a little more than 1. And so for now, if we want, we can just leave it as 12 elevenths of an ohm. Cool. So that is our parallel connection. It's in series with this 1 ohm resistor up here. And so now what we're going to do is add those in series. And so REQ in series is just going to be 1 ohm plus 12 over 11 ohms. And at this point, I just evaluated this out. You get 2.1 ohms after rounding. So that is our equivalent resistance. And again, anytime you get to that point, it's probably good practice to box that number because it's an important number. All right, so now let's calculate the current that is leaving our battery. We're going to use our old friend Ohm's law. All right, so Ohm's law gives us the voltage drop as a product of the current times the resistance. We're looking for the current here. It's going to be V over R. The battery in our setup was putting out 6 volts, and we just computed a total equivalent resistance of 2.1 ohms. So this is going to be a little less than 3 at 2.87 amps. Okay, so that is going to be the current that is leaving the battery, and it is the current that passes through our 1 ohm resistor. So we already have that done, which is great. Now we need to calculate what's going on for the parallel part of our circuit, and for that we go to Ohm's law again. For parallel, you want to remember that they have the same delta V. So what is that delta V? Well, it's going to be our current, 2.87 amps, times the equivalent resistance just for that connection, which we said was 12 ohms divided by 11. And so this ends up being a little more than 3.13 volts. So that's going to be the same for the 2, 4, and 6 ohm resistor. And in order to figure out the current through each of those, we're going to use Ohm's law yet again. All right, so for Ohm's law, it's V equals IR. And so I is V over R. And this is going to be 3.13 volts. Now for our 2 ohm resistor, let's write this out. This is the 2 ohm resistor. That is 1.57 amps. For the 4 ohm resistor, it's going to be the same potential drop divided by 4 ohms. So you can see it's going to be half of what we just calculated here. 0.78 amps. And last but not least, the 6 ohm resistor, 3.13 divided by 6 ohms gets us 0.52 amps. And again, as a check, you would want to add these three together. And what do they need to equal? Well, they had better equal what we calculated up here. Add these up. We got 7, 15, 7, carry 1, 5, 12, 17, 18, carry the 1, 2.87 amps. Exactly what it needs to check out as.